Hi, this is Mrs. Boykin with another at-home video talking about how to describe the domain and range of a transform parent graph, and also how do we write the end behavior statements of some of these transform parent graphs. Well, let's review. The domain refers to our x value, and basically we're looking at a graph, we're reading it, we're not memorizing anything, but we're reading it, and we're asking ourselves, what is the smallest x value? And then, what is the largest x value? And we're writing those as statements. Now, in some examples, it might be that we would have x such that x is an element of all real numbers. That means that on the x-axis, it's starting at a negative infinity and going to a positive infinity. Or maybe it's more restricted. And maybe we might have a statement such as the following: the set of all x such that x is less than or equal to a negative 3. Similarly, we can have ranges. Also, they can be open, such as our domain, and we can say that y such that y is an element of all real numbers. That's if it went from negative infinity to positive infinity. Or we can also have restrictions on our y such that y can be greater than or equal to positive 2. So we can have different examples, and it's all based on reading the graph. So let's look at some examples and we'll see what we're talking about. Okay, here's an equation. It is cubic. The parent function is a cubic. And we see it's to the third power. So let's talk about the domain. Well, the domain is what is the smallest x and what is the largest. So if I'm reading along the x, I can see that I'm going farther out and farther out. And don't forget that this graph is going forever in both directions. So when we look at the x values, they are going further and further down the negative scale, and they're really not going to stop. So we can say that x such that x is going to negative infinity, but then over on the right, as it's going up, it's starting to creep a little over farther and farther to the right. The arrow never ends, so it too will also reach x of positive infinity. What's hard about this is we often look at the line or the graph, and we think that, well, the graph really isn't moving to the right, it's pointing up. Well, look again, because we can see that as we move farther and farther, we are creeping down that x-axis. And again, it goes up, but it also moves to the right. Okay? So, let's take a look now at the y values. So the y values are my range. Y such that, well, what's the y doing? Well, we can see here it's at 0, it's at negative 1, negative 2, negative, it keeps going forever down to negative infinity. And on the y-axis, it's climbing up, 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 it's going to positive infinity. So we can see that y is an element of all real numbers. So in our cubic graph, even though it's been translated, we have x and y both are an element of all real numbers. So let's take a look at the end behavior statement. So remember, this is the statement we say as x is approaching, and we look, what is it doing on the left? Well, as x is approaching negative infinity, where's f of x pointing? The end is pointing down. So as x approaches negative infinity, f of x, or our y values, we said are pointing down, which means negative infinity. Okay, let's look at the right-hand behavior. Well, on the right, we're heading to positive infinity. So as x is approaching positive infinity, f of x is approaching, where's it heading? The end is pointing up to positive infinity on the y-axis. So that is your end behavior statement for your cubic graph. Let's take a look at another one. Here's our logarithmic graph. When we type it into the calculator, we don't typically put the base number 10 there. The calculator automatically inserts it unless you put something other than the number 10 there. By writing nothing is the same thing as just saying log of x plus 2. And we can see in our log function that this has been shifted 2 units to the left. Don't forget, this is also going down forever, and it's also going to the right forever if we put arrowheads on it. Well, let's talk about the domain. Oh, another thing that I wanted to point out about this graph is we have a vertical asymptote. If I erase this arrowhead here, because it's hard to draw real accurately with this, we can see that right here, it's like there's an imaginary line, and this graph is running so close to this vertical asymptote. It's practically laying on top of it. That's how close it is. So we can say the domain. What is the smallest x value I found? Well, if this vertical asymptote is at a -2, but it never touches it, we would start out by saying that the domain x, such that x at the smallest end is -2, but what about over here on the right? It goes forever to the right. So x is greater than or equal to a -2. That means the smallest that it was the -2, or barely -2, I should say. And I made a mistake. I shouldn't have, I'm so used to putting or equal to. This never touches the -2, so we do not put the or equal to piece in there. And we can just say x is greater than a -2. You never saw anything over here past the -2. So let's talk about the range. Well, don't forget, the range is my y values, and I'm pointing down, and it's going to go forever to -infinity. And as I'm coming up, I know I'm traveling to the right, but am I climbing at all? I am. So we say x such that, oh, there we go again, it's too late in the day for me. Y such that y is an element of all real numbers. Why? Because it went from -infinity to +infinity. There was no restriction. All right, now let's talk about the end behavior. What is the graph doing on the left? Well, if I'm over here and I'm buzzing along, as x approaches -infinity, I'll never get to -infinity because my domain is restricted. So we would say as x approaches -2. Couldn't get any smaller than that. What is f of x doing? Where is my arrowhead pointing? Well, this is pointing down, so it's going to go to -infinity. Now let's take a look at the behavior on the right and describe it. As x is approaching, well, over here on the right, we said the x continued forever. So it's going to approach +infinity, and f of x is approaching, what's it approaching? It seems like it's going just to the right, but is this distance growing larger and larger and larger as we go to the right? If so, that means it's also climbing up, and it eventually will reach +infinity. Our next graph is a square root graph. And of course, with our square root graph, we have a beginning, and I'll put a little point right here. And just ask yourself, what is the ordered pair of this point? Well, +1, 2, 3, 4. And over here, +3. So this ordered pair is 4, 3. Okay, so let's talk about the domain. Remember I said, what is the smallest value that the domain can be? Well, we say x such that x is what? It's not smaller than 4, it's greater than 4. And this point says it also can equal 4. So it's greater than or equal to 4. Because it continues forever on the x-axis to the right. And don't forget we have our arrowhead here. My range is my y values. Y such that, well, what's the smallest y could be? Well, the smallest on the y scale is 3. Could it go bigger than 3? Yep, it's going up as it moves to the right. Can it go lower than that? No. So we can say y is greater than or equal to +3 because that's the y value, reading over to the y-axis. Okay? Now let's talk about the end behavior. The end behavior of this graph on the left-hand side, we're going to say as x approaches what? Well, x is never going to approach negative infinity like our typical statements say. As we travel, as x approaches positive 4. What is f of x approaching? Well, up here it's 5, 4, well actually 6, 5, 4, and it approaches 3. So this is a very different statement than what we're used to seeing. Again, traveling to the left as x is approaching 4, f of x is approaching 3, just like the ordered pair 4, 3. Okay, let's talk about the right-hand side behavior over here on the right side of my graph. As x is approaching, well, on the right, where do we go? We're going to positive infinity. Where's f of x pointing? Well, you might say it's pointing sideways, but remember, it's at 3. Here it is at 4, 5, 6, 7. It's going to keep on going to positive infinity. I understand that it's really moving much quickly to the right, more so than it's moving up, but nonetheless, it is climbing. So we have to notice that. The next graph is our quadratic. So let's talk about the domain. Well, down here at the very bottom, at my minimum, I'm moving up, and we can see that the width is getting wider and wider and wider, and it's never going to stop. So we can talk about the domain as x such that x is an element of all real numbers. That graphic, if it continued forever, would keep getting wider and wider, and eventually it would encompass all the way from negative infinity to positive infinity on the x. Let's talk about the range. Is the range all the way down to negative infinity? No. This is the smallest y value, and what is that smallest y value? That's a negative 2. So it's starting at negative 2, but I can see that it is going up to positive infinity. So we would say y such that y is greater than, and in this case, we have a point there, or equal to a negative 2. Okay? The end behavior, we've talked about end behavior of quadratics before. And on the left-hand side, as I'm going, I see that I'm moving along the x, and it's heading up and it's moving to the right. So eventually, I'll get to negative infinity. Well, what's f of x doing? The arrowhead said it's pointing to positive infinity. Over on the left-hand side of my graph, as x is approaching, well, it's getting bigger, 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 bigger on the x. It's eventually going to reach the positive infinity. Where's the end pointing? It too is pointing up to positive infinity. And that's all that we have for today on end behavior and talking about domain and range. Please review some of the other graphs to prepare for your transformation quiz. Please don't forget your 10 different parent graphs. Be able to recognize not only what the graph looks like, but also the name of the graph, the parent equation, we should be able also to write the transformed equation. And don't forget, we're going to talk about reflections, where it flips over the x-axis. We're going to talk about any stretching or shrinking. Those are dilations. We're going to talk about translations, where we move left or right or up or down. So we need to be able to talk about or write the transformed equation given a graph. Don't forget, we also have to be able to discuss the intervals of increasing and decreasing. And I talked about that on a previous video. also the domain and the range like we did on this video. And the last thing is our end behavior. And that will prepare you for your next summative assessment. This is Ms. Boykin signing off. I hope this little video helped you. I know it's a little long, but I wanted to give you plenty of examples. Make sure that you study for our test and come to Cab Morning if you have any questions. Thanks, guys.